Trouble figuring out the vertices. Could you go over that? I am so glad to go over that. Okay, we must be talking about graphing inequalities, so we could definitely do that. Okay, so let me get my math lab going. I'm still here, don't worry. You can probably see me, but I can't see you at the moment. Okay. And let's see, what else do I have to do? There are all these steps. There now, can you see that? Bet you can, because I've, on my part of it, what yes. I have is a red thing around the screen, and that's a sign that the screen is being shown as opposed to me. How offensive. Okay, we're going to find a vertices problem first.
Like number 19.
Thank you. All right. There we go. Is it graphing or just the vertices?
It's the vertices. I can figure out the graphs, but I can't figure out how to do the vertices.
That's great. Okay. All you're going to do is solve a little matrix, okay? Just a little system. Notice that here, well, you might not be able to see it, so I'm going to write it large up here. What this problem does is it gives you these two inequalities. Okay, and so you've gone through and you've graphed them, you've found the shadings, you've put it in my math lab, and now it asks you to find the vertex or the vertices. And so what you do is, since the vertices, there are only two lines here, they're going to cross somewhere. That's the vertex right there, okay, where the two lines cross. And then you'll have the shading somewhere, maybe there, wherever it is. So now you need to find where they cross. So you turn these into lines. And you proceed to solve this system any way you like. Now, it's sort of already set up for you to solve it with elimination. And here, unlike with the bigger 3x4 matrices that we were working on, these little guys, it doesn't matter whether you start getting rid of the X or getting rid of the Y. So this is already set up for you to add each column together and eliminate the Y's, because you'll have Y minus Y. Well, that's pretty handy. You don't get that all the time. So x plus x is 2x, and y minus y will be 0. And 5 plus 6 is 11. So you'll have 2x equals 11. And x equals 11 over 2, which is 5.5. But the instructions say, well, it doesn't really say, does it? Type an ordered pair, use a comma to separate. So I wonder if it would take 5.5. I don't know. But let's assume it doesn't. And so now you can take 11 over 2 and put it into either one of these equations and then solve for y, the other letter, or you can go ahead and do elimination again. It's up to you. If you wanted to just substitute 11 over 2 for x, you might want to use the first line, so you would say 11 over 2 plus y equals 5, and then subtract 11 over 2. So you would have y equals 5 minus 11 over 2, which is easy enough to do. However, most people have trouble with fractions. So if you want to use your calculator, and if you've got a TI, yeah, there we are. Okay. Waiting, waiting, waiting. Yes. Oh, come on. These things are problematic. Okay. Well, I am going to go back to the blank screen here, which is probably what you would have. And you would say, okay, 5 minus 11 divided by 2. 5 minus 11 over 2. And if you want to, you can hit enter. And then if you don't know what that is, you can math frac it. And you'll get negative 1/2. So that is what your y would equal, which would be negative 1/2. You can always do it by hand if you want to. Okay, so 11 over 2 comma negative 1/2. It has you find the vertex first, it appears. So let's see. 11 over 2. And then, and I always have bad luck with this. Let's see. Okay. Negative 1 divided by 2, which is 1/2. And then check my answer. It's not going to let me check my answer.
You need to graph before you can check your answer.
Oh, gross. Okay, I'm going with that as the answer, but that's how you always find a vertex. If you have a problem where you have something like this, and this was one of the homework problems, and it ends up that that's the shaded area, and then this is a vertex, this is a vertex, and this is a vertex. What you do is you set up a system like that, but this vertex occurs at the intersection of this line, and this vertex occurs at the intersection of this line, and that vertex occurs at the intersection of that line and that line. So it's all going to be the same, it'll just be different lines.
Now, when we're answering the question for any of the vertices, does it matter what order we put them in?
Mm-mm.
Even when we're doing the 3 on like a triangle where the one that you just showed, where
Yes.
there's 3 points, it doesn't matter what order they're in.
Order doesn't matter.
Okay,
Whether you've got the right numbers in it, that matters.
correct.
Okay, and that was problem number 19. Okay, now I can't see the chat, so you're going to have to speak up and tell me which number to go to.
Could we do number 1?
Mhm.
Thank you.
You haven't completed it. No, I haven't. That's terrible. Okay, these are evaluation problems. This is one of the main things you do with functions. So let's say this is number 1. And they give you a function, f of x equals 3x squared minus 5x. And they want to know f of 0 and f of -1 equals, and f of 2 equals. Okay, so here we're going to say 3 times 0 squared minus 5 times 0. That's going to be 0 minus 0, which is 0. So whatever number is in the parentheses, you put in for the x over here, and you calculate an answer. Negative numbers are particularly dangerous. You have to put them in parentheses, or you could mess up totally. 3 parentheses -1 squared minus 5 times -1. Now I'm going to mark that out and bring it down here, so I'll have more room. Okay, so this is going to be 3 times -1 squared. The 2 just goes to the -1. So this is -1 times -1, which is +1. So this will be 3 times 1. Then minus 5 times -1 is plus 5. Now you've got 3 times 1 is 3, plus 5 is 8. So f of -1 is going to equal +8. Now 2 is a positive number, significantly less dangerous. You're going to have 3 times 2 squared minus 5 times 2. This will be 3 times 4, because 2 squared is 4. 2 squared is 2 times 2. So you're going to have 12 minus 10, and the answer will be 2. So f of 2 equals 2. And that's how you would do those three. Whatever goes in the parentheses goes in for the x.
Thank you.
You're welcome. Next question.
Number 14.
14. Ah, perpendicular. Yeah, those are among the hardest problems. Well, what you have to remember is that parallel lines have the same slope, the same exact slope. But for perpendicular, that's not true. All right, and we're going to be looking for a perpendicular line. And this line is perpendicular to this line. And this is number 14. Okay, now you use this equation, which is called the given equation. You use this to find the slope of this line, and that's what we're going to do right now. Okay, and this perpendicular line is going to go through 6, -2. But we get to that later. Right now we have to use this line to find the slope of this line because this slope is going to be related to that slope. So I subtract 7x from both sides. Yeah, I don't want to do that. Okay, so 7x minus 7x is 0. Bring down the plus 9y. And over here, we always put the x term first. So I'll say my -7x, and then since 8 is positive, I'm adding 8. So we have 9y equals -7x plus 8. Then to get y by itself, to solve for y, we divide by 9 and divide by 9 and divide by 9. It's easier to just go straight to that step. Every number gets divided by 9. Every term gets divided by 9. So y equals -7/9 x plus 8/9. Okay, this is what we care about though. We have just found, working with this line, that the slope of this line is -7/9. Now, if we were working with parallel lines, we would use that slope to find the equation of the parallel line. But we're working with a perpendicular line, so we're going to have to change the slope in a certain predictable way. So let's use the point slope formula. Y minus y1 equals m times x minus x1. So we're going to have y minus -2 equals m times x minus 6. This slope is the slope of the perpendicular line. So we're going to have to take the slope of the line it's perpendicular to, and this is what happens to that slope. We'll have y plus 2 equals, it's going to be the opposite sign and the reciprocal. So +9/7 times x minus 6. Okay, I'm just waiting. Questions about what we've done so far? Okay, now we have a fraction there and it's kind of ugly, you know, and it's not related to the 6 at all. So there's a trick to make it easier to solve this equation, and that trick is to get rid of the fraction. And the way you get rid of the fraction is you multiply it by its denominator. This is what's going to happen. Of course, if I multiply this side by the denominator 7, I'm going to have to do the same thing to the other side. But let me show you why we're going to do it. Here we've got 9/7 times x minus 6. The denominator is 7. If I multiply this by 7/1, which is just 7, so I'm multiplying by 7.
Oh.
Yeah, the 7 up here and the 7 down there cancel. So I'm left with, on the right-hand side, 9 times x minus 6. Because here you would have a 9/1, and 9/1 is just 9, right? So that's how you get the 9. Now I can't do anything to one side of an equation without doing it to the other side also. So I have to take this 7 and also multiply it by y plus 2. And then I'll distribute, I'll multiply the 7 by the y and by the 2. So I'll have 7y plus 14. And then I have to distribute the 9 over here. So we'll have 7y plus 14 equals 9x minus 54. I'm not done, but sort of giving you a breather to think about what we've done.
So this is only done when we're figuring a point for a perpendicular line.
When you're finding the equation of a perpendicular line, yes.
Okay.
All right, this line is going to look kind of like this. So what we're trying to find is, thank you, a line that looks like this. Okay, and crosses this line, which is 7x plus 9y. Equals 8. That's the line we were given. It's going to look kind of like that because it has a negative slope. We're trying to find the equation of this line, a line that's perpendicular to this line, and that happens to go through 6, -2. This red line will go through 6, -2, and it will be perpendicular to this line, which means it crosses at a 90-degree angle.
Okay.
Good. More questions up to this point? Huh.
Can you do question 21?
Yes, I can. I better find some place to save this, though. Here you are. You guys are CA live streaming because we live stream. Okay, I'm going to, there. Now I've saved it. Now I have to worry less about losing it if something terrible happens. Okay, now we're going to continue. Let me continue this and finish it up. I need to solve for y, so I'm going to get 14 out of the way first by subtracting 14 from both sides. 14 minus 14 is 0. Okay, so I've got -54 minus 14, or you can look at it as I take away 54 and then I take away 14. How much have I taken away? Well, that will be minus 68. I will have taken 68 whatever's away. So I'll have 7y equals 9x. Okay, 9x minus 68, and I'm going to divide by 7 divide by 7. Now, I don't believe that 7 will go into 68. In fact, I know it won't. 7 will go into 63 evenly, but not 68. So our equation is going to be y equals 9/7 x minus 68 over 7. And now this is the equation of this red line that's perpendicular to the line we were given. Yes. To me, this is the hardest part right here when you're dealing with a perpendicular line. To be specific, this part to me is the hardest. Yeah. Once you've multiplied by 7, it's a little less dangerous because you're just solving an equation. Are there any more questions about number 14? Okay, I'm going to solve it. I'm going to save it. Ah, there. Okay. And ask, what's the next one? What's the next toy in our playground?
21.
Okay. Ooh, yes. Okay. The difference quotient. Got to go step by step. That's the trick. Okay, so number 21. You're finding the difference quotient for f of x equals 6x squared plus 5x plus 7. Okay, and I'll write it up here. F of x plus h minus f of x over h, where h is a very small number, very, very small, like 0.001 or 0.0001, really, really small. Okay, and what we're trying to do here, the whole reason for going to this trouble, is to find how fast something is changing on this line. It's not a line, it's a parabola, so let's call it a curve. On this curve, whatever that would represent in real life. Okay, so I know what f of x is. I've already got that. I have to find what f of x plus h is, and I have to actually calculate it. So I put x plus h in for each x. Now, it would be delightful if we could just say x squared plus h squared, but you can't. Not when it's added or subtracted. So we have to actually write down what this thing is. When you square it, it multiplies by itself 2 times. But over here, this is pretty basic. You just take the 5 and multiply it by the x and multiply it by the h. Okay, now I'm going to have 6 times, and I'm going to calculate what this is. So I'm actually going to come down an extra line so that I can write larger. Because how we're going to multiply this is I take this x and I multiply it by that x, this x and multiply it by that h, this plus h and multiply it by that x, and this plus h and multiply it by this plus h. Okay, so what about the 6? Well, we're going to wait and then bring the 6 into it. We are going to use it, so don't worry about that. X squared plus hx, and I put h in front just because h is a number. If you were the researcher, you would know exactly what number that is, but because it has so many decimal places, you just write the h because it's easier. Okay, now before I multiply through by my 6, not multiply through, but distribute the 6, notice that I have these like terms that I can add together. If I do that first, I'm a little bit less likely to make a mistake. So x squared, I have 2 of them, so this is 2hx plus h squared, and I write the rest of it down just because I don't want to forget it. Ugly 7. Ah. All right, so now I'm going to distribute the 6. This will be 6x squared plus 12hx plus 6h squared plus 5x plus 5h plus 7. And that is what f of x plus h equals. Okay, so all of this would be step 2. The very, step 1, all of this would be step 1 because you already know what f of x is. You have to find out what that is. So this is all step 1. Now, step 2 is where you actually do this. You find out what that is if you take f of x plus h and you subtract f of x. And you have to be very, very careful to put f of x in parentheses so you don't make a sign error. It's so easy to make a sign error. I know, I love to make sign errors. So f of x plus h, and leave off plus h's, minus f of x. Is this big enough for you to see first? I didn't even ask. There. Well, no, I have to. Now I can't see what it is. There. Okay, so here's f of x plus h. It's 6x squared plus 12hx plus 6h squared plus, oh yeah, I don't need that. Yes, I do. 5x plus 5h plus 7. Okay, here's our f of x plus h, and I'm going to write it over that. Okay, now I'm going to subtract f of x, which is 6x squared plus 5x plus 7. Wish I could make that go away, but I guess I can't. Okay. Oh, it went away. Okay, so now I don't really need these parentheses around this long part. So I'll just say 6x squared plus 12hx plus 6h squared plus 5x plus 5h plus 7. Here's the hard part and the dangerous part. You're going to distribute this minus sign in here and in here and in here. It's just like multiplying -1, which is basically what you're doing. This will be minus 6x squared minus 5x minus 7. Okay, now we're going to eliminate like terms because invariably you're going to have some like terms, like for instance, 6x squared and 6x squared. 6x squared minus 6x squared is 0. And 5x minus 5x is 0. And 7 minus 7 is 0. So that what you're left with is 12hx plus 6h squared plus 5h. And that is what f of x plus h minus f of x looks like. And then finally, step 3. The difference quotient is f of x plus h minus f of x over or divided by h. So I'm going to take f of x plus h minus f of x, which is what this equals. I do this because I know I'm going to be canceling. And I'm going to divide each term by h. And I'm going to cancel. This h and this h cancel. And one of these h's is going to cancel with that. And this h and this h cancel. So that now I can see that my difference quotient is 12x plus 6h plus 5. Now, for those of you who took calculus in high school, You know the short way to find the difference quotient. In fact, you know the difference between the difference quotient and a derivative. We are not taking a derivative. We're taking the difference quotient. The difference quotient still has an h in it. The derivative is what you get when you let h shrink down, 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 to where it's so close to zero, you can't tell the difference. So people who have had calculus almost always get this wrong because they think they can leave the h out. You can't. In fact, the h is a specific thing. It's 6 times h. And if you were doing some science problems, that would represent your error in measurement. So you actually have to keep the h. So remember that. The h is important in some disciplines. So keep your h. You can get rid of it when you get to calculus, but not at first. Okay, I had to throw that in because there are invariably some people who took calculus in high school and they're taught shortcuts, which are good. I love the shortcuts, but not here. You can't take a shortcut here. Okay, and this was number 21. What do you want to go over now? Okay, but do you want to, I didn't even ask, and that was, are there questions about this? It's very, very mechanical. Okay, it's very mechanical. You do it with 3 steps, you do it slowly and carefully. You especially try really hard when you get to this step to not make a sign error. It's messy, it's ugly, so you have to be very, very careful when you're combining your like terms, because it's hard to see them. Okay, now what was the problem you wanted to see?
31.
Is that what the person said?
Yes, ma'am.
Okay, 31. Ooh, okay, of course. Had to happen. All right, here we have a system of 3 lines in 3-dimensional space. We're finding where they intersect, and that of course means we're going to use a matrix. Negative 4x minus 3y minus z equals 1. Negative 8x minus 2y minus 2z equals 2. And 6x plus 3y plus z, 1z. So I'm going to actually write the 1 and put the 1 up here. Okay. Equals negative 1. And then I've got negative 4, negative 8, 6, negative 3, negative 2, 3, negative 1, negative 2, 1. And you have to be especially careful because look at the distance between that minus sign and the 3. Okay, that minus sign goes with the 3. It's going to be negative 3 when we write it as numbers. In fact, it is so easy to make an error with all of these negative signs. I'm going to do something first. First, I'm going to write out matrix 1. -4, -8, and 6. -3, -2, 3. And -1, -2, 1. And 1, 2, -1. Okay, it just occurred to me, if you're going to make a mistake with that minus sign and not put it onto the 3, that mistake is going to happen before you get to matrix 1. And you'll be leaving the negative signs off the 3 and the 2. So before we even get started with that, just mark through it or X through it. Remember, especially on a test, you're thinking survival. What do you need to do to survive? And this is a completely acceptable thing that you can do. Before you even get started, if there are just too many negative signs, multiply the whole line by -1. And multiply this whole line by -1. And you don't have to multiply the third one. Okay, now what that's going to do for you, you don't have to, but it's just, I think the more negative signs you have, the more dangerous it is. So if I multiply -1 by each number, all 4 numbers, I'm going to get +4x plus 3y plus 1, z equals -1. And then over here, I'm going to do the same thing. I'll multiply this -1 there, and there, and there. Okay, and there, and there. So I'll have +8x plus 2y plus 2z equals -2. And then we'll let line 3 stay the same, 6x plus 3y plus 1z equals, it's already a -1. Now, most of the numbers are positive now, and you're just not as likely to make a mistake. So -4, -3, -1 becomes +4, +3, +1. We'll have +8, +2, +2, and 6, 3, and +1, just looking in the coefficient matrix here. And then these two numbers become the opposite signs. And now we're ready to create matrix 1, and it's not going to be anywhere near as hard, I don't think. So now we get rid of the letters, and that makes it easier too. And also remember that the instructions say use Gaussian elimination or Gauss-Jordan. You never have to use Gauss-Jordan. I think it's too hard for beginners. You can give it a try. I think you should use Gaussian, which is what we've been using until you get really good at it. And if you go on to finite math, you can start using Gauss-Jordan to your heart's content. Okay, so I'm going to take 4, 8, 6, 3, 2, 3, 1, 2, 1, -1, -2, -1. Row 1, row 2, row 3. We call them rows now. And you have to keep your goals in mind. Your role for matrix 1 and 2 is to end up with a 0 in this position right here. So my strategy to be able to do that is going to be to take, well, because I know 4 goes into 8 2 times. What I'm going to do is I'm going to take, and you might not do exactly what I do, and you don't have to, but there you go. I'm going to multiply all the numbers in row 1 by -2. And the reason is I want this to be a -8, and I want to add it to a +8. And then I'll just add it to row 2. Now that's my way of doing it. Let's look at other ways you could do it. You could multiply all the numbers in row 1 by +2 and add it to all of the numbers in row 2 multiplied by -1. That would give you +8 minus 8, or +8 plus -8. So there are different things you could do. There are different alternatives to end up with the same thing. But okay, what I chose to do is to take -2 times row 2 and add it to at -2 times row 1 and add it to just row 2, or 1 times row 2. There are some calculator and computer problems, computer programs and calculator programs that require you to put a 1 in front of a row when you're not going to change it. It's just the way the program works. Okay, so I'm going to take -2 times 4, that will be -8. -2 times 3 will be -6. -2 times 1 will be -2. And -2 times -1 is +2. Down here, I'm just going to write row 2. That'll be 8, 2, 2, -2. Now -8 plus 8 is 0. -6 plus 2 is -4. -2 plus 2 is 0. And 2 plus -2 is 0. That's allowed, but it's a lot of zeros. This is going to be my new row 2. So I come down here and I write matrix number 2. Why? Because this is the way Gauss did it. And when you use an organized method, you can actually move faster than if you try to use your own. Row 1, row 2, row 3, I'm going to have 0, -4, 0, and 0. Right now, row 1 and row 3 are staying the same. 4, 3, 1, -1 is what row 1 is, and row 3 is 6, 3, 1, -1. Okay. Now, having done that, incidentally, if you had had all zeros in here, or all zeros in the coefficient part of the matrix, and then a number out here, you would know something was terribly wrong. Actually, it might not be wrong, but they might not intersect. Or they might all be on top of each other. Or two might be on top of each other. So there are different problems with this. So I took a sigh of relief that I at least have a -4 there, even though the rest are zeros. Now, my next goal, you don't have to understand what I just said. You will understand someday if you go to finite math. My next goal is to put a 0 in that position, which means I'll be working with row 1 and row 3, because working with row 2 would not help me put a 0 there. Any number times 0 is 0, so I would add 0 to some number here. It just wouldn't work. So I have to look at row 1 and row 3 and ask myself how I can add these two positions together to make them equal 0. And so I stop and think, well, what is the smallest number that 4 and 6 would both go into? And the answer is 12. Go into evenly. Although you could use 24 if you wanted to. 6 times 4 is 24. I try to go for the smallest number because it's easier in the long run. So what I'm going to do is this. I'm going to take 3 times row 1. And I'm going to add it to -2 times row 2. Now what this is going to do is 3 times 4 is 12, -2 times 6 is -12, so 12 plus -12 is 0. That will get me my 0. Notice that my whole motivation is getting a 0 in that place right there, and I don't really care a lot about what happens to the other numbers. So go ahead.
Isn't it supposed to be row 3 instead of 2?
Yes, thank you. Very good. Because we're definitely using row 3 and not row 2. Okay, so we've got 3 times row 1. And what that means is we multiply every number by 3. So 3 times 4 is 12. And 3 times 3 is 9. 3 times 1 is 3. And 3 times -1 is -3. And then -2 times row 3 is -2 times each of the numbers in row 3. -2 times 6 is -12. -2 times 3 is -6. -2 times 1 is -2. And -2 times -1 is +2. And I add vertically 12 plus -12, which is the same thing as 12 minus 12, is 0. 9 plus -6, or 9 minus 6, is 3. 3 minus 2, or 3 plus -2, is 1. And -3 plus 2 is -1. So this is going to be my new row 3. And now I come down. And this is going to be matrix 3. Row 1, row 2, row 3. This will be 0, 3, 1, negative 1. And these two rows stay the same from matrix 2. 0, negative 4, 0, and 0. And 4, 3, 1, negative 1. I have one more move with row operations to make, and that is to put a 0 in this position right here, while I keep my 0 there, which means the only row I could work with would be row 2, because any number I multiply by will be, when I multiply 0, I'll get 0. So now I want to put a 0 in this position. I'm going to be adding negative 4 and positive 3. And again, 3 times 4 is 12. So if I were to multiply row 2 by positive 3, three times row 2 plus 4 times row 3, this is what would happen. I'd have 3 times negative 4 is negative 12, and 4 times 3 is positive 12. That would give me a 0 in that position. So here we go. 3 times row 2 and 4 times row 3 will give me this. 3 times 0 is 0. 3 times negative 4 is negative 12. 3 times 0 is 0. And 3 times 0 is 0. Okay. And now 4 times 0 is 0. 4 times 3 is positive 12. 4 times 1 is 4. And 4 times negative 1 is negative 4. So 0 plus 0 is 0. Negative 12 plus 12 is 0. 0 plus 4 is 4. And 0 plus negative 4 is negative 4. And so matrix 4 is going to be my last matrix. Most of the time using Gaussian elimination on a 3x4, that is, there are 3 rows and 4 columns, you're going to have 4 matrices. So this is still new row 3. So I'll come over here, row 1, row 2, row 3. I'll have 0, 0, 4, and negative 4. And then these 2 rows stay the same in matrix 3. 0, negative 4, 0, and 0. And 4, 3, 1, and negative 1. And notice that we now have a lower triangle of sorts of zeros. That means using Gaussian elimination, we're done with our row operations, and we're going to go back to an XYZ system. So here is how I'm going to rewrite these. 4x plus 3y plus z equals -1. Negative 4y equals 0. And 4z equals -4. Well, you can tell right away that in this little equation in row 3, and that's what back solving is. So this is called back solving. This is where we started. And what you do is you solve at row 3, then you go up to row 2, then you go back to row 1. And so first you solve for z, then you solve for y, then you solve for x. So you go backwards. Back solve. Okay, so if we have 4z equals -4, then when I divide both sides by 4, I'll get z equals -1. And up here, I'll have -4y equals 0. And -4 times what is going to equal 0? I can divide both sides by -4. I don't really have room to do that. Divide by -4, divide by -4, and I get 0. So y equals 0. Okay, now, c is -1 and y is 0. I'm going to go up here and put a 0 in for y and a -1 in for z. So what that's going to give me is 4x plus 0 plus -1 equals -1. So I can add the opposite of -1 to both sides. Well, first, 0 plus -1 will give me 4x minus 1 equals -1. Well, I need to solve for x, so I'll add 1 to both sides. And this is really guaranteed to mess you up because people are going to panic and say, I can't have a 0, can I? Yeah, you can. Sure you can. So 4x plus 0 is 4x. 4x equals 0. Divide by 4, divide by 4. X equals 0. Can I do that? Yes, you can. I can even draw you a sort of graph of where that would be. But let's write out our ordered triple first, which is going to be the answer. Z is -1 and the other two numbers are 0. So what x, y, z equals, here, we'll even say it like this, x, y, z equals 0, 0, -1. Now, I'm going to show you where this is. This takes, wow, okay. You have to use your imagination here. If this is the x-axis, this is the negative x-axis. Now I'm going to do this at a slant, but it's for a reason. If this is the y-axis, then this is the negative y-axis. If this is the z-axis, then this is the negative z-axis. So you're in 3 dimensions. Negative 1 is located 1 unit underneath the very center. So if you were just looking at an x and a y axis, here's 0, 0 right here. X is 0 and y is 0. Z is coming out of the screen at you, but negative 1 is going to be into the screen 1 unit right below what we call the origin, the very center of the x and the y axis. So it's a real point that really exists. You could say it's 1 foot down in a hole. The steps are the most important part. You use R1, starting out you use going up. You use R1 and R2 to zero out this position. Then you use R1 and R3 to zero out that position. Then you use R2 and R3 to zero out this position. Then once you have your lower triangle of zeros, you are ready to start back solving.
Are the problems on the practice exam the same as the problems on the normal exam?
Each version, each of you will probably have different numbers, but it's the same problem, just
Okay.
using different numbers. And this problem was number 31.
On the practice exam and on the practice exam, will we have to scan in and submit our work?
Yes, thank you. Let me show you where I put it. Maybe. There's my math lab. Okay. I'm going to get rid of that and go over here. If you know that modules is where all of your study sheets are and lecture videos. Well, if you go over to modules and come down to, I haven't done it for this class yet. Let's do it right now. Right now, I am going to make module 5, which is week 5. Week 5. Week 5 exam. And the review homework is for another class that's still doing review homework. I'm not sure yet what you all are doing. We'll look so you'll know. But anyway, this is week 5 exam week. I'm going to save module number 5 down here. And then, let's see, I'm going to make a new page. No, I'm not. I'm going to make an assignment. A new assignment that says scan or photo of scratch paper. Neat scratch paper so I can read it, because then I can give you not extra points, partial credit. If I can read it, say you miss a problem, but I can read your work, I can give you back points.
And now
And-
this will be for both the practice exam and the actual exam?
No, I'm sorry. It's going to be for the real exam.
Okay,
For, I guess I should say, real exam. So I'm going to go back. I'm going to edit, scratch paper for exam 1.
Will there be a
There.
time limit on the exam?
No, I don't impose one. I don't know what ProctorU does, but I've heard that they don't impose one either.
thank goodness.
So this is going to be 1 point, and I have to do that. It has to be some points. Now, no submission. Yes, you're going to submit online, and what you're going to submit is you're going to upload either a scan or a photograph of your scratch work. And there are lots of free apps that will give you scans. Adobe has a free scan app. Microsoft has a free scan app called Microsoft Lens. And of course, there are lots of others, but they're all free. Or you can pay for fancy things, but the free version is more than enough. Allowed attempts. You have as many attempts as you want to get that scratch paper up because it might cause you problems, right? The first time you do something. Plagiarism review, like I give a rip about that. And English teachers care about that. So, yes, and I'll fill out all of this due part. Well, I guess I'll put the 23rd there. However, you can do your test today, tomorrow, the 21st, the 22nd, or the 23rd. Now, I do need to check on something though. Until, I don't know. I don't even want to leave until done. We're not going to until anything. Okay. Yes, let's look at MyLab Mastering. And go to teacher part. I have a whole bunch of links there. Now let's go down here to where the exam is. Okay, I said 922, but then I changed it to 923. Now the first day, okay, I don't know what I was thinking because this, factoring polynomials, a review of that, because you're going to need it. We are going to do that. We're going to pick this up on okay, this will give me a good chance to look at the date. Now, you're going to have until the 23rd to turn in your exam at 11:59. No sympathy for people who go over. Yeah. However, I had thought that perhaps I'll be here on the 21st, but I thought we would not study anything new and still give you a chance to review for the exam. But on the 22nd, I will be back with bells on, and we're going to start reviewing factoring. Okay, now, you might remember factoring, in which case you don't need to be here, or you can just watch the videos afterwards. So I'm not saying anybody has to be here on the 22nd, but there's too much material for me to let you take a whole week off. So, yeah. I don't know. I might give it till the 24th. Let me think about that so that you can have 21, 22, and 23 without any new material. After you take the test, you can be catching up That would be a good idea, wouldn't it? Yeah, if you've got the test on either the 21st or the 22nd or the 23rd next week, that's Monday, Tuesday, Wednesday. On Thursday, we'll start reviewing factoring. Okay, so let's make this the 24th, Thursday the 24th, and that's not really new material, but nobody likes factoring. And that's it, you won't have any new work until Thursday the 24th. So you get to work on your homework and you get to work on your practice exam. And I think personally, the best way to study for the exam is to take the practice exam over and over and over and over and over. You can take it an infinite number of times if you could live that long. Does that sound okay?
Sounds good.
No new material till Thursday. Now, if you're asking me why start Thursday, and it's just because it feels better for me. Okay.
Thank you.
Are we over? Yes. Oh, and we have gone over. So you are free to go. If you have a question you wanted to ask but didn't get to, I'll stick around.
Thank you.
Thank you, Professor.
Thank you. You have a very good day.